Welcome. Today's presentation will explore the anthropogenic or human-induced drivers of climate change. We will examine the major contributing sectors, their environmental impacts, and the strategies available to mitigate these effects. Anthropogenic climate change refers to long-term shifts in the Earth's climate, primarily driven by human activity. Notably, atmospheric carbon dioxide levels have now reached 420 parts per million, the highest in over 2 million years. Since the Industrial Revolution of the 1850s, global temperatures have risen by approximately 1.1 degrees Celsius and continue to rise at an accelerating rate, showing no signs of stopping. But why is this important, and how can we address it? To answer these questions, we must first understand how Earth retains heat. The greenhouse effect is a natural process in which certain gases in the atmosphere, such as carbon dioxide, methane, and water vapor, trap heat from the sun, keeping the planet warm enough to support life. However, human activities, particularly the burning of fossil fuels for energy, transportation, and industry, have significantly increased the concentration of these greenhouse gases. This has intensified the greenhouse effect beyond its natural balance, leading to accelerated global warming and widespread climate disruption. The principal human-driven contributors to climate change can be divided in the following sectors: fossil fuel combustion, deforestation, agriculture, industrial processes, and urbanization. Each of these emits greenhouse gases or alters natural carbon sinks in significant ways. Firstly, the combustion of fossil fuels, including coal, oil, and natural gas, represents the largest source of anthropogenic carbon dioxide emissions. These fuels are extensively used across multiple sectors, including electricity generation, transportation, manufacturing, and residential heating, making them deeply embedded in modern society. When burned, they release vast quantities of carbon dioxide into the atmosphere, far exceeding what natural systems can absorb. Another major driver of global warming is deforestation. Forests function as major carbon sinks, absorbing atmospheric carbon dioxide. When they are cleared or burned, the stored carbon is released, contributing significantly to greenhouse gas concentrations. Deforestation is responsible for approximately 10% of global emissions. Agriculture is a vital part of our lives and the foundation of our food security. However, modern agriculture practices contribute to climate change through potent greenhouse gases. Livestock produces methane through digestion, which is 28 times more potent than carbon dioxide at trapping heat, while synthetic fertilizers release nitrous oxide, which is 265 times more potent than carbon dioxide, and depletes the ozone layer. Additionally, land use changes such as deforestation for agriculture further exacerbate emissions and reduce carbon storage capacity. An additional driver of global warming are industrial operations, including cement and steel production, that release large volumes of carbon dioxide. Cement manufacturing alone accounts for about 8% of global emissions. Also, chemicals such as ammonia and plastics typically rely on fossil fuels and present significant challenges for decarbonization. Lastly, urban development contributes to climate change through increased energy consumption, emissions from transport, and land surface alterations. Currently, cities consume roughly 75% of global energy, much of which is derived from fossil fuels, and are subject to the urban heat island effect. This refers to the phenomenon where urban areas experience significantly higher temperatures than surrounding rural areas. This is primarily due to the dense concentration of buildings, roads, and other dark paved surfaces that absorb and retain heat more effectively. This can lead up to a difference of up to 10 degrees Celsius in cities in comparison to rural areas. But why is the increase in global temperature such a critical issue, and why should we take action to address it? Since pre-industrial times, the planet has already warmed by approximately 1.1 degrees Celsius, and if current trends continue, scientists project a temperature rise between 1.5 degrees Celsius and 4.4 degrees Celsius by the end of the century. While these numbers may seem small, even slight increases in global temperatures can lead to dramatic and widespread consequences. We are already witnessing the effects. More frequent and intense weather events, such as heat waves, hurricanes, droughts, and floods, are becoming the new norm. Rising sea levels, caused by melting glaciers and thermal expansion of the oceans, pose an existential threat to coastal communities, with an estimated 340 million people at risk of displacement by 2050. Climate change also drives ocean acidification, biodiversity loss, and public health challenges. Ocean acidification, caused by oceans absorbing about 30% of human-emitted carbon dioxide, leads to harmful effects like coral bleaching, such as the loss of 50% of the Great Barrier Reef since 2016. Biodiversity is also at risk, with around 1 million species facing extinction due to habitat loss and climate change, including a projected 30% decline in polar bear populations by 2050. Human health and food security are threatened as well, with over 500,000 deaths per year expected from heat stress by 2050, crop yields for wheat and maize declining by 5% per 1 degree Celsius of warming, and mosquito-borne diseases like malaria and dengue spreading to new regions. But while the challenges are immense, we are not powerless. The window to act is still open, and the actions we take now can determine the future of our planet. Let's explore the solutions, innovative technologies, policy changes, and everyday actions that can drive meaningful change. A critical mitigation pathway is transitioning away from fossil fuels. Renewable energy sources, solar, wind, and hydropower, now provide 30% of global electricity and must be expanded further. Electrification of sectors such as transport and heating is essential. Additionally, decarbonizing heavy industries requires innovations such as green hydrogen for steelmaking, carbon capture and storage technologies, and circular economy practices like material recycling, all of which can substantially reduce emissions. If we want to continue to live on this planet, we also need to maintain it. Preserving forests and restoring degraded ecosystems are vital strategies. Approaches include financial incentives for conservation, large-scale reforestation projects, and empowering indigenous communities who are proven stewards of carbon-rich forests. Sustainable agriculture can mitigate emissions through regenerative practices, dietary shifts toward plant-based foods, and methane-reducing technologies. Such measures help maintain soil carbon and reduce reliance on high-emission practices. Effective climate action requires both policy-level interventions and behavioral change. Instruments like carbon pricing, subsidies for clean technologies, and the elimination of fossil fuel subsidies must be coupled with public engagement and lifestyle changes. In conclusion, human actions are the primary force behind the current climate change. The severity of future impacts depends on our decisions today. With existing technologies and policy frameworks, we have the capacity to limit warming and protect planetary health. Immediate, collective action is imperative.